Hi, I'm Joel Woodward, an application engineer for Agilent Technologies. Many engineers like measuring signals with high dynamic range using oscilloscopes. I'm going to talk to you about 3 techniques that will lower the noise of your oscilloscope so you can measure small signals and large signals at the same time. And then we're going to do a real-world comparison of Agilent's Infiniium9000 series scopes with LeCroy's HRO 6ZI models. One of the techniques is to use oscilloscopes that have higher bits in their A to D converters. One key consideration for this is as oscilloscopes are able to quantize smaller and smaller values, the scopes need to have front ends that have less and less noise so that the noise doesn't outweigh the quantization ability of the scope. Technique number 2 is averaging. Averaging requires multiple oscilloscope acquisitions, and what happens is as the oscilloscope is acquiring over multiple acquisitions, it will average each individual point, thereby eliminating noise associated with the oscilloscope. A third technique is called high-res mode, and this one is less well known amongst engineers. In high-res mode, oscilloscopes that have more sample rate than is needed for the bandwidth can perform over-sampling, and then it will average all of those samples within a single acquisition and create a single Y-value point. Again, thereby eliminating internal noise that's deterministic from the oscilloscope. What I'd like to do is show you a real-world compare using LeCroy's HRO 600 MHz oscilloscope. It's a scope that has 12-bit ADC. And I'm comparing that to an Agilent 9000 series 1 GHz unit that also has a 12-bit mode in high-res mode. You'll see from the comparison that in 12-bit mode, both scopes have nearly identical bandwidth. And the Agilent scope, because it can sample 10 times faster, it performs better high-res mode without a bandwidth reduction than the LeCroy scope. Also, both scopes are equivalently priced. If I look at a noise floor comparison of the 600 MHz LeCroy HRO versus the Agilent 1 GHz bandwidth limited in high-res mode to just under 600 MHz, what you'll see is they have almost identical noise characteristics. They're both very, very low noise. Some engineers like to look at spurious-free dynamic range as another metric of signal quality. In high-res mode, the Agilent product has the same spurious-free dynamic range as the LeCroy 12-bit oscilloscope. So let's look at a real-world comparison. I have a setup where I've input a 600 millivolt peak-to-peak sine wave from an Agilent MXG that has very, very low noise on it. And superimposed on that waveform, I have a very tiny 2 millivolt pulse that happens each time at the peak of the sine wave. Let's see what it looks like on both the LeCroy 12-bit scope and the Agilent 9000 series scope in 12-bit mode. Both oscilloscopes are set up identically. At the top of the screen you can see the full sine wave, and then I've created a separate zoom window that shows the small pulse injected on that wave. If I look at the oscilloscope running freely, it's hard to discriminate the attributes associated with that small pulse, and in fact if I do a single run after a single run, it's really impossible to tell any specific characteristics about it. To achieve higher dynamic range, what I'm going to do is turn on averaging, and if I turn on averaging equals 64, now you can see that the small pulse pops out and I'd be able to measure it with a higher degree of accuracy. LeCroy, like Agilent, also offers a high-res mode. Based on the limited sample rate of the HRO models of 2 gigasamples per second, turning on high-res mode doesn't always help because it has such severe bandwidth reduction. In this case, you can see turning on high-res mode eliminates your ability to see the small signal fluctuation. I have the Agilent oscilloscope set up with identical settings. As Agilent has 10 times the sample rate, we can move the oscilloscope into high-resolution mode, select 12 bits, so we're also achieving 12 bits of resolution, turn on averaging, and when I run the scope, you'll see that we get identical measurement results. We've talked about 3 techniques to make higher dynamic range measurements with oscilloscopes. More bits on your A to D converter are effective, but only if the noise of the oscilloscope is associated by an equivalent amount to take advantage of those extra bits. Two other techniques that we've looked at, averaging and high-res mode, can be very effective for looking at high dynamic range measurements. And in the case of the Agilent Infiniium9000 series, you've seen that we can achieve equivalent measurement results. Interested in knowing more? Contact your Agilent sales rep for a demo. Thanks for watching the video.